In this tutorial, we are going to be making a sinkhole effect using real footage, so if this interests you, keep watching. Okay, so we are in Blender. The only thing that I need you to have ready before we start this tutorial is I already have the camera track. This isn't a camera tracking tutorial, so I'm just going to skip that step. Let's make a sinkhole out of this footage. So, to make a sinkhole, what do we need? We basically need to make a bunch of particles that somehow inherit the color of the ground, and then we're going to basically make a bunch of rules that say swirl in this vortex shape and do a whole bunch of stuff, okay? Long story short, we need particles. So I'm going to start off with a plane, and I have it positioned so that it's where I want my sinkhole to be. If it isn't, you just move it. And again, it's camera tracked, so it will follow the footage. Put a plane where you want your sinkhole to be. We're going to spawn particles on this, but more importantly, we need to spawn particles that have the color of the ground underneath it. Right, so we somehow need to extract this texture. So this is all going to be geometry nodes, but to extract the texture, we're going to need to do a bit of baking. So shading workspace, go to the plane. By the way, all the blends are going to be available on Patreon if you want to follow along using the original file. So in cycles, what I'm going to do is I'm going to make a material designed to bake out this texture in this tiny little square. So we need to start off by projecting the footage. So with the image texture, I'm going to use the exact same footage that I'm using in the background for the tracking. So for me, that's called sinkhole base. And you can see, oh, there's the image texture, but it's not projected. So just make sure that your footage is going for a lot of frames, at least more than the thing is elapsed. Mine's like 170 frames. Make sure these two are selected, and then for the coordinates, and this is just classic baking, you want to use windowed coordinates. What this is going to do is, if we look at film transparent, as you can see, it's kind of taking the section of the footage that's on the plane and projecting it, and it's going to follow, only from the camera view though, okay? So again, if I disable overlays, we've somehow captured it. What I want to do now is I just want to find a frame where all of this is in frame. So if I go too close, that's not good because some of it's been clipped out and you can see it does weird stuff. Just find kind of the last frame where it's all in there so we get as close as possible and we get the highest resolution, and we're going to bake from here. Where are we going to bake this to? Again, we're just making an image texture. So we're going to make an image texture. I'm going to make a new one. It's going to be 1,000 by 1,000 roughly. Interesting thing about this is I just made a video about what is a terabyte. Is it 1,000 or 1,024 gigs? But whatever. So I'm going to call this bake for tutorial. And it should already be using these, but just in case, we're going to make sure these are using UV coordinates. So what we're going to do is we're going to bake from windowed coordinates from the video. We're going to bake from windowed coordinates to UV coordinates on this blank image, okay? If you've never done baking before, you have to be in cycles, you have to be in CPU, and you want to drop this number to like 100 because this is what it's using to bake. In the bake panel, I know we're doing a lot. We haven't even gone to the particles, but it's necessary. Make sure this is an emission because we want to bake basically the raw feed. It's just emitting. There's no BSDF, there's nothing. A raw emission without anything in the boundary. Make sure your object is selected. Make sure it's selected. Make sure your node is selected. This is very important. And hit bake. And you're going to see what's going to happen is it's baking down here. And then in this image right here, you can see it's kind of extracted the pattern that exists inside the square. So you want to make sure you save this, by the way. Alt-Shift-S. I'm going to call this baked texture for tutorial. Okay, if you don't save this, it's going to wipe because that's how Blender works. Okay, what does this mean? What is all this nonsense? Well, we had a projection material that depends on the camera view. What we've done now is we've baked this into a image texture. And again, this is the, I guess we could just load it in raw, the bake texture for tutorial we just made. We did this off of UV coordinates, so now you can see it's stuck on here, which is the beauty of it. And from the camera view, it's still going to make sense because, it's motion tracked. The beauty of this, though, is now when we spawn particles, it can inherit the color, including these little popcorn. People should pick up after themselves. It's going to inherit the color from the thing, okay? If you don't know what I'm talking about, welcome to the club. I don't know what I'm talking about. But we'll now do the geometry node setup. And let's also save. So in geometry nodes, now we're getting into the particles. So again, what we've done is we've extracted the texture, and now the name of the game is to get the particles to pull that texture and spin and stuff like that. So with geometry nodes, I'm actually also going to open up the shader editor for this. Before I spawn any particles, before I spawn any particles, I want to make sure geometry nodes can read this texture. So we have geometry being fed in, fed out, nothing special. What I'm going to do is I'm going to import this image texture. Which one? Why do I have to keep importing it? I do not know. You'd think it'd be saved into the list, but what did I call it? I called it something with the word texture. Am I tripping? What was it called? It was called Bake for Tutorial. Okay. It doesn't seem to like that. Is it already in the list? Yes, it is. Okay, fine. Seems like I was the one that's wrong. So we have this Bake for Tutorial texture in geometry nodes, and I want to make sure that it's using this appropriately. To test for that, what I'm going to do is I'm going to make a material that's going to be on this plane. So again, the geometry, the plane is being pulled in. We're applying a material, which is why I went blank, and then we're going out. For the material, I'm going to make a new one, and I'm going to call it particles, because that's what it's ultimately for. And we're going to know it's going to work because when we import in this material, it should just look black. So let's use the particles material, and it's working, okay? So all I'm trying to say here is we've linked a material to geometry nodes, okay? Particles, particles. Cool. Now we got to make sure that we can bring in information of this image texture into the shader editor, which is weird because normally we just put it in the shader editor, but because we're doing stuff with particles, we need it to work here. So what I'm going to do is I'm going to use this image texture, feed it as an output, and then in the output, I'm just going to call this text for texture. Now in the attribute, I'm going to load this in. So again, we have image texture sent out of geometry nodes. We called it text. Now we're bringing it into the shader editor and applying it. And you can see it does something because, you know, the material is here. But what you're going to notice, and this is a very important point, is that it's just a color. It doesn't look like our image texture. What you're going to learn from this is as we subdivide, we're actually going to get more and more resolution. You can almost see the pattern. The reason this is the case, and it's also shifted, we'll talk about that. The reason this is the case is unlike the shader editor, where you can just like load in an image texture and it's going to be fine. In geometry nodes, we're on a point-by-point basis. So each of these points now has a single color, which means the more points we have, the more of the texture we get. So in other words, our resolution is now geometry-based. This is the point I was trying to make, okay? So, but we can see the information's being pulled in here, but we need more geometry, so I'm just going to throw down a subdivide mesh. And that's clean. If you want to get even cleaner, you can go even cleaner. It's up to you. The resolution of this matters because I believe the particles that we're going to spawn that are going to pull this texture rely on how much texture was here to begin with. That might not be true, but that's what I'm going to operate under. Okay. Next, as you can see, this is offset. It just so happens that it's offset by half, both on the X and Y. And you can either fix that by using a position coordinate. So here's kind of the dummy approach. It might not even work because we're assuming our plane is a certain size. But the dummy approach is you take your vector math, you add 0.5, and you can see even that doesn't seem to do it correctly. That's like one approach. What I recommend is we somehow need to use our UV map in here. So we need to bring in UV information. To do that, I'm going to make an attribute sent in here. And this wasn't possible somewhat recently, but now it is. So you can see we have a new input. That input, I click this button. What it does is it lets us bring in a field or a vertex group or whatever. And there's one inherently called a UV map for every mesh. So I'm going to import that in. And you can see now it's perfect. Why? Because the UV map is sent in here. Now the image texture is using the UV map. It's sent out as text and sent into the shader editor. It's a lot, but we just put a step in between. The beauty of this, though, is now everything is set up to add particles and have them inherit the color. So let me show you how to do that. So let's distribute points on faces. We'll worry about, and you can already see the color here. We'll worry about the swirling later, but You could see as I increase the density, it seems like they're capturing the colors correctly. Now let's check. If I lower the resolution, does it affect the thing? Like if I was to, let me see an unsubdivide. This isn't part of the tutorial. This is just me experimenting. Let's try that again. Unsubdivide, 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 unsubdivide. It does it seem to matter? Huh. Maybe it doesn't. That's a cool insight. Either way, I'm going for high geometry just because that's what I banked off with. Either way, so we're going to distribute a bunch of points. And what we want to do with this is we want to have them, first of all, only be in a circle, and then we want them to swirl. So first of all, how do we get a bunch of points, but only in a circle? To do this is going to be a bit of a challenge. To do this, we somehow need to describe a density function, right? What controls the number of points that says only have it in a circle. The way we do this is use position coordinates. We're going to use vector math. We're going to say, look at this position, tell me the length. In other words, right here at the origin, it's going to have a length 0, the size of the vector, and then it kind of grows outwards, right? We want that, and we want to say, hey, tell me which of these vectors are less than some number, okay? Let's see. We plug this in here. You can see it only gives us a single point. We plug this in here, and then we multiply it by like 100, and you can see it gives us a circle. Let's do 1,000. It gives us a circle. As we increase the size of this, it's going to increase the size of our circle until we hit the bounds, and now it's a square. So I'm going to find kind of the biggest number that works here. Again, the reason this works is we're basically saying, hey, give me all the vectors that are in scale less than some number radially, so it's a circle, and then multiplied by 1,000 so that there's a higher density inside that circle, okay? So we have this. They're still going to inherit the colors. You can almost see the pattern here. And now what we want to do is for each of these, we want actual geometry that you can see. So I'm going to instance on points. You could do a cube, you could do whatever. I'm going to recommend a grid because it almost doesn't matter what our particle is going to be. So I'm just going to make it the lowest res thing possible. In fact, can I go down to 2 by 2, make it super tiny, and let's see. Okay, doesn't have the material anymore. We'll talk about that. But you can see each of these points now has a grid that we can control the size of. And this is geometry that you can actually see. Okay, to make this actually visible, we need to realize our instances. So instances on points, what does it do? It outputs 3,000, in this case, instances, right? Let me get rid of this viewer. We need to turn that into actual geometry so that the material can be applied. And boom, you can see we get our color back. The way I want you to think about this is we're going to do our kind of simulation. We're going to do the rotation. But the way I want you to think about this is the higher the density, kind of the more detail resolution we get. And once we make this a very big number, like 10,000, we also want to make the particles smaller. And that's eventually going to fill in this grid. But for now, we're going to do a low-res version, okay? So let's actually just look at the distributed points. How do we get these now to swirl? Because if we now swirl these, actually if we do anything to these, and this is kind of the key insight here, so I'm going to set position. If I do anything to these now, the texture should stick, as you can see. And this is kind of the beauty of using geometry nodes for this. We've already applied the this attribute in some sense, the color. So no matter what we do to this, it's going to follow along. It's like the texture is being moved with the motion, right? So the question is, what motion is going to make it rotate? Well, let's type in vector rotate. That seems, useful for this. And what we're going to do is we're going to take their original positions. We're going to take their original positions and rotate them. Okay? And let's actually have that be their new position, not an offset. So you can see now, even a rotation, it's going to stick with it. And from the camera point of view, we have this little patch of texture, and we rotate it, and we can do whatever we want with it, right? Okay, cool. So now the question is, what's the correct function to plug in here? Well, what I want to have happen is it all swirls the way it is, but the swirling happens more in the center and kind of less in the outskirts, right? As it gets closer inside the whirlpool, right? The vorticity, the swirling gets more intense. Again, we want a radial gradient for this in the same way that we made the circle. In fact, we can kind of pull from this, I suppose. I'm just going to make a new one to keep it clear. So we want to pull from the length information. If I plug this into the angle, you can almost see it's a little hard to tell. But if we take this and multiply it, what it's going to do is it's already creating this nice swirling effect that we want, but it's almost the opposite, where it swirls the most on the outskirts and the least in the middle. We're going to invert that. But this is working, again, because we have a length function that looks at how far away from the center are we. Okay? Again, every time I say okay, like, okay, I feel like a fucking chicken. Ba-bak. So it's the same deal, but we just want to invert it. So what I'm going to do is I'm going to take this. Actually, let's keep the multiply. It's going to be useful. Let's just take it and invert it. And I'm going to add a bit more control with this map range. So from 0 to 1, go to 1 to 0. And now you can see when we multiply it, we have the exact opposite. Like it's doing very little on the outskirts and a lot in the center, which is kind of like almost all we want. A couple things we can do is I'm going to make this a smoother step. So the transition from how much it's swirling kind of looks a bit more. You can see the boundaries a bit more held down. So this is before. Look at the boundary. It's kind of spinning, right? Because it's very close to not spinning, but it is a little smoother step. Kind of constrains the boundary in this way that I like. Okay. So now we're going to take this. I'm going to set this to be controlled by time. And let's have it go even a bit faster by multiplying it by 5 or something. Okay. Now, what I did for my version, of course, is I had this animate over time. So first there wasn't a whirlpool and then there is one. You can do that with some keyframes, but we're not going to do that for here. So we have this spinning. So you can see it's almost like swirling the texture. Swirl the texture, right? That's what it looks like. A second component to this is it should be a sinkhole. It should be being pulled down. So let's add that component, and then we'll call it, then I'll show you how to render this thing, which is actually a bit challenging, and then we'll call it done. So with the position, I also want to offset it on the Z, and we could do that as its own thing here. So we're going to combine X, Y, Z. We need some kind of Z function that says pull down the middle, but not the thing. And again, we have, that's literally what these radial gradients are. So I'm going to use another radial gradient. This one I'm going to set to linear for a reason I'll explain in a second. And we're going to plug this into Z. Okay, it's kind of working. But we want it to go the other way. So I'm going to set this to -1. Is this what we want to do? No, I think what we want to do is maybe let's just... It's the same thing, but let's take this and multiply it by -1. Okay? The difference being now is, let's look at it from the side. See, by the way, it's going to be a little hard to look at it from the side because they're grids. They're perfectly flat, so you kind of have to go like this. Multiplying it by -1 is going to give us an opportunity. Yeah, it's going to give us an opportunity to shape this in kind of a more intuitive way. So what I'm going to do is I'm going to throw in Rgb curves because right now it's just kind of a straight line. And you can imagine that this is the profile of our sinkhole. So I'm just going to do something like that, just so it kind of looks sinkhole-y, whatever that means. Kind of flatten it out. And now not only is it going to swirl, but it's going to be kind of, it's going to go down some. So for our position, we remapped it with vector rotate. For the offset, we offset it. So before, after, okay. And to make it kind of like actually a sinkhole where there's kind of a void here, we're going to do that in the material, not geometry nodes. You could have it expand in geometry nodes, but I'm not going to do that, okay? We'll do it in the shader. It looks better anyways. Okay, so I think we're done with geometry nodes. So here's what this looks like. It starts off normal, and then it starts swirling, swirling, swirling. In fact, I might change my original version. I like the way this one looks. And again, we're always going to up the resolution on this. But to get there to be a void, I'm going to do it again in materials. So what I want to do is I want to look at texture coordinates. And if you think about it, if I kind of look at this from the side, I can say kind of, whoops, I need overlays for this, kind of tell me once we're at this point in terms of height. And I guess let's flip the view. Once we're at this point in terms of depth, let's call it like that, then we'll start making it transparent or black or something like that, okay? So I'm going to look at object coordinates. I'm going to look at separate x, y, z, not the x, not the y, but the z, which is all going to look black because we need negative numbers. So I'm going to subtract. There we go. And what I'm doing is I'm creating this gradient. Again, they're grids, so you have to kind of... I'm creating this gradient as we go down in the z, and we can say, use this gradient to kind of mix the original thing with some transparency, right? So we have this, we're going to take it, we're going to mix it with a shader. Which one? Transparency. Use this as the factor, view it, and let's see, what do we have so far? It does not seem, let's look at what we have so far. I feel like it's not doing it correctly because this isn't harsh enough. So I'm going to add a color ramp. So I want the black to really kind of clip in here. Yeah, is that what we want? And then make the white really white. If we put this here, what does it look like now? It does not seem to be respecting our transparency. Give me a second to think about why that is. Okay, I figured it out. I think I just flipped these incorrectly, so I'm going to flip them. Boom. Now we have a sinkhole. In fact, do we even need this color ramp? I don't think we do. I basically had it so the top was transparent and the bottom was color. I had them mixed up. But now you can see we kind of have this void because it's getting transparent as it goes further down. But from our view, it looks like it's a radial effect. Okay? So we look at this from the camera view, we disable overlays, and look at that. Okay, so I think we're ready to do a render of this. So now that we have the basic effect, and by the way, you could go more complicated with this. You could say, oh, have this go through a principled BSDF, and for that you need lighting and all this. I'm not going to go that crazy. This gets you 95% of the way there. But once we're ready for this, let's up the resolution so it doesn't look so blurry. So again, the way we said we do that is by adding particles. And you could see just multiplying it by a few gives us pretty much everything we need. And you equivalently want to scale these down enough so that, they're not overlapping, but so that there aren't huge gaps in between. It's fine if there's tiny, tiny gaps. And we could fill in those gaps using more. And again, for a final render, you definitely want more of these. But one thing that's going to save us, let's do a test render, by the way. So we're going to use GPU, 100, denoise, optics. It's actually going to render pretty quickly. So you can see it looks okay. There's too many gaps in between. The thing that's going to save us is because this thing has a swirling motion, enabling motion blur is actually a big deal because now each of these is going to have their own trail. And you could see it kind of fills in the gaps just a little. I mean, not too much, but it does help. If you set it to 1, it should do it a lot more. Yeah, now you can really see it's filling in the gaps. So just remember, there is motion blur, but clearly our gaps are still too big. So I'm just going to up this number, and that should fill it in. And you can, again, play with this. Okay, so now we get into one thing that I found pretty complicated, because you think, okay, take this, slap it over the render, what's the big deal, right? Or over the footage. I'll show you what the big deal is. So we take the movie clip, we overlay them using alpha over, and you can see it kind of does what it's supposed to do. The only issue I'm seeing here is this void is not a void, it's just showing the footage underneath, right? So we have this render. It's looking fine here, here, here. But as we get into here, there should be a void. And by the way, as we kind of go into the sinkhole, we have a decrease in transparency. That should also be a bit black. None of that's going to come through because our footage is just underneath. So what we need to do is we somehow need to create a mask. And alpha isn't really going to do it. We're going to need to make a custom mask that tells the footage, hey, don't render here. Somehow. Here's how we are going to do that. We're going to actually use render layers. So if you haven't used render layers, get your butt ready. So this is our main render layer. Everything we've done, I'm going to put in a collection if it isn't already. This is our main collection. Our main render layer has a main collection. Okay? What I'm going to do is I'm going to add a new object being, you don't want to use a circle because it does have some depth, but I guess you can't really see under it. You know what? We'll use a circle. In my original, I used a cylinder. So we're going to add a circle with a lot of geometry, and this is basically going to be our mask shape, if you want to think about it that way. So I'm going to fill this in, and I want it to be just the size of our simulation, or our geometry nodes. And basically, wherever we see the circle, we want to say, hey, don't render the footage, okay? We're going to take this circle and bring it out and put it in its own collection, because if we were to render this, you can see it's kind of covering everything up. So we somehow need to put it in its own render layer. Or we could put a cylinder. No, I'm going to go with the original plan. So plus you'll learn something about render layers. So because this needs to be in its own render layer, I'm going to put it in its own collection called mask. And the key idea here is we don't want to see mask here. So we can hit E, or you can just hit this checkbox to disable it. So it's as if it's not there. And then in a new render layer, which I'm going to call mask, we only care about the mask and not the main. Okay? So what am I saying here? I'm saying main has the whirlpool with the mask disabled, and mask has the mask with the whirlpool disabled. Why is this useful? It's useful because now when we render, it's going to render this. It's also going to render our circle. And nothing's changed yet, right? We haven't done anything. But now in compositing, in the render layer, you can now go to mask, which has this circle. We care about its alpha, really. And this alpha is going to say, hey, inside this alpha, do not render footage. So for the footage, this footage, we can set alpha. It turns out we want to invert this, it seems, so that white is saying keep footage here. We want it to be everywhere else. We're going to set the alpha for the footage. So here's the footage. Here's the set alpha. So now we've cut a void in the middle. Then we're overlaying it. And we could do a bit of work at the boundary, as you can see. But you can see this fixes all the problems. To get this to be cleaner at the boundary, I'd recommend using a dilation. So we want this to feather inwards, something like that. It's either that or the opposite. Let's see. Yep, that does it. That's clean. So you can see we have this. We have the thing cut out with the feathering. And then we have the whirlpool. And as we render, because this is motion tracked, it's going to be correct. Now, the only thing I would say that I've overlooked in this tutorial that is very important is, again, the swirling increases as we begin. But at the beginning, there's no swirl, but we still have this depth. The depth should be starting off at 0 and increasing over time. So if you know what I mean. So let's actually fix that. So we have this offset, okay, multiplied by -1, fine. What I'm going to say is let's have it be the way it is on frame 40. But in the beginning, as it's just swirling, I'm going to multiply this by 0, so it doesn't have any depth. So you can see it goes downwards. So it swirls and goes downwards. So let's see what it looks like on an early frame where there's no depth. Okay, beyond this artifacting, beyond the artifacting, it does look pretty good. And what is this artifacting, really? That is strange. Might be some view layer stuff. But either way, not important to this tutorial. And then as this opens up, it does the correct thing. Beautiful, beautiful, beautiful. Only thing is, do we want to clamp this? I don't think it actually matters. But you can control the depth of this, obviously. Okay. So I think that's the essence of it. I'm trying to think if there's anything I've overlooked beyond that artifact, which I don't have the brain power to figure out right now. But this is it, right? The only thing I would add to this is I would add a BSDF to this so that it actually has shadows as it goes inwards. But again, that's a bit much for this tutorial. The main thing I wanted to teach is the baking the texture, using that information from geometry nodes to shader nodes in the whirlpool. So with that being said and done, this was probably a long one. Yeah, 30 minutes. Let's wrap it up. So at the end of these tutorials, as you people who watch my videos a lot, you long-term followers know, I always like to promote the Patreon, but let me tell you why you might actually want it, and it isn't just an ad at the end of these things that you want to skip. So when you join my Patreon, there's a link in the description. You get 3 benefits. The first one is you get to watch videos early. So you could have seen this early. Whatever. I mean, it's a nice perk. You can comment before other people. You can see the tutorial a day or 2 early. It's a thing. The second one is where I think most of the value is. You get the blend files. So you can actually use the blend file, not the one I made here, but the one I used for the original video. You get the blend file that I used. You also get hundreds of project files because I've put up stuff on Patreon since 2019. So you get blend files for hundreds of projects. Any tutorial you've seen I've made where I'm like, this is going to be on Patreon, you can find it there. And then thirdly, exclusive tutorials, which I've made a few of, maybe like 20, something like that. I make them every once in a while. You could watch tutorials that are only for the patrons. Those get to be pretty in depth, depending on what they are, because I'm like, who cares about a time limit, right? So if any of those things interest you, or if you just want to support these tutorials that are available for free. And by the way, the scrolling things, there's 730 some patrons. It's because of these patrons that I can keep making these tutorials free. So if you want to join that effort, please do. Every dollar is very useful, especially when there's so many people, and that combines. So the most direct way to support me and the CG Matter channel is via Patreon, or if you're interested in it because of the benefits that exist too. I want to thank all the active patrons. I want to thank everybody for making it to the end of the video, and hopefully you learned something, and I'll see you in the next one.